All right, so here's a problem when a ball is thrown horizontally off of a 30-meter cliff, and we know that it lands 200 meters away. And there's a couple things we want to know: how long is it in the air, how fast was it fired, and what's the final velocity. So the first thing I see is that it's horizontally off of the cliff, so that I can see that it's going to go straight off and land down. The cliff is 30 meters, and it lands 200 meters away. So I can set up my table here, my V0, V final, A, delta XT for the X and for the Y side. And I can start to put some pieces in. Since it says it was thrown horizontally, well, horizontally means it's all in the X. And there's nothing in the Y direction. So we put a 0 in there. And that means my velocity is all in the V, or in the X. So I just call that V. Acceleration in the X is always going to be 0. There's nothing making the object speed up or slow down in the side-to-side direction. So we can put a 0 in our acceleration port in the X. Acceleration in the Y is always 9.8, or 10 if you want to use that. And it's always down. We can call positive up. So in this case, we'll call it a negative 10. Delta X is 200 meters. That's how far out the ball goes. Delta Y is 30. That's how high the cliff is. And it's down, so we put a negative sign with that. We need V, but the problem is we only know two things on the X side. And that's not enough to solve for that. So what we need to do is we need to use the Y to find out the time, and then we can slide that over because the time for the X and the Y are going to be the same. So we'll start with our delta Y equation in this case. Delta Y is V0t plus 1/2 AT squared. Negative 30 is our delta Y. Our initial velocity is 0. And we have 1/2 of the acceleration, negative 10. And t is what we're looking for, t squared. So we do a little bit of algebra. And we find that t is the square root of 6, which is 2.45 seconds. So we can put that on the Y side. And again, since they're equal, we put it on the X side. Now we can do our delta X equation. Delta X equals V0t plus 1/2 AT squared. Our delta X, remember, is 200 meters. That's how far out it goes. The velocity in the X is just V. That's all the velocity since it's fired only in the X direction. And we know that the time is 2.45 seconds. So we can use that to find out then that the velocity needed for this to happen is going to be 81.6 meters per second.